I'm going to have this talk now. That is the title, as Elisa already said, on the Wave 4.0 in the medical domain, trends and technology. This has been a topic that I've been dealing also together here in the Institute, in the Fraunhofer IESE in Kaiserslautern. So in the department that I manage, so we deal with virtual engineering and simulation and digital twin strategies, how we can support hospitals and all types of medication therapy and stuff like that. So I'm gonna just skip this introduction information slides because Elisa already provided background information about myself. But yeah, so I come from Brazil. So I'm here in Kaiserslautern since 2009, and yeah, I have had several roles here. I also made my doctorate here in Kaiserslautern. Yeah, so this is just some information about the Fraunhofer. So sometimes we speak about Fraunhofer and people ask, yes, so can you tell us a little bit more about Fraunhofer? So we offer consultancy on the innovation front from companies in the different sectors. So we do not act on the basic research. So what we do is to get this knowledge and transfer this to the point to the other side of the industry to have really the applied technology. So yeah, we are involved also, of course, we have to be involved in research projects, right? Because we have to somehow evolve and develop the knowledges that we apply to the different companies. And so here just put some yeah, the references to some of the research projects. In the medical domain or in the health domain or digital health, so we have some specific activities going on. So not only with local hospitals like this Westphal Klinikum in Kaiserslautern, but also national-wide and also at the European level projects. That's quite exciting for us. So I know that the IESE, we were supposed to meet in Salvador, in Bahia, so I had my talk tailored for that situation. But just to give an information on that for you, we do have collaboration, strategic collaboration, long-term with one of these three big hospitals in São Paulo. So there you have these three biggest hospitals in that city that are very well-known. And we have a long-term collaboration with them already on technology transfer. So yeah, so we are also involved in this field. So yeah, these are some companies that we also do, and I included this here because, like as I said, the IESE was supposed to be in Brazil. We're supposed to be there, but the National Agency for Sanitary Affairs of Brazil and other companies in the private sector. So going to the point, guys, we're going to talk about healthcare and this overall evolution that we have seen, right? So what we are observing these days is this wave going on, and everybody's talking about the 4.0 wave, right? Everything now is 4.0. If you want to have some project proposal accepted, or to have a big potential to have that accepted, claim that you are doing something in the 4.0, right? So this has this has been a big hit. But what people do not understand sometimes is where this whole story comes from. Right, so if we have a 4.0, yes, this is exactly the case that we had a 1.0, 2.0, and 3.0 in these different domains. So when it comes to the health domain, the evolution from healthcare 1.0 to the 3.0, I didn't hit the 4.0 yet. So we had in the 1.0 that doctor that goes to the houses of the patients and have a one-to-one relationship. It's almost like a priest to that house, right? So whatever that doctor says becomes somehow the rule on the house when it comes to health issues. So it's really on this one-on-one relationship. When we jump to the healthcare 2.0, in this case, we're talking about when all these technologies like electronics and even computation technology, they become in place to have more accurate and precise diagnosis, right? We're talking about X-ray machine, pulse oximeter, and all these MRI, and so on and so forth. When we jump into the health 3.0, and this is where we are at the moment, where the world is in terms of healthcare. We are transitioning from this 3.0 to the 4.0. But on this 3.0, we have somehow the blend of what we had in terms of technology, but now not only that you go to the doctor, and then he's going to say, give me the result of your MRI, and that's what you have. You should have this, this, and this treatment. The idea with the Health 3.0 is that you can bring the human somehow in place, but not as we had in the 1.0 with this one-on-one relationship, but that the human is also in the loop together with the technology. So you have patients going back to the hospitals and to the doctor, to the medical practices, and sometimes not even an image exam is necessary because the doctor is going to really talk and understand what's going on with the patient. And this is exactly just a relation, just a summary of this 1.0, 2.0, and 3.0. Just that this is just a summary if anyone would like to have a deeper look later on in these slides that I believe is going to be available. So I just put it here as a summary of everything that I just spoke with you. 1.0, health 1.0, 2.0, and the 3.0. But okay, but we are here to listen about health 4.0, but what it is exactly health 4.0. So in the health domain and in the projects that we support, the different medical and health institutions, we have learned the following, guys. We have to learn from different domains. We have to learn from different domains in order to understand what one specific context will mean for another context, right? So I do not know if you guys know this story that Steve Jobs was sitting in the garden of his house with John Ivey, and they were thinking what would be the next, how the next generation of iMac computers should look like. And they thought, and nothing came. And John Ivey was looking at this nice flower here, and this sunflower, and he said, we should have a computer that will look like this. And those guys started to have interesting conversations, and then they came to this, and after that, they came to that. So if you read this book of Steve Jobs by Walter Isaacson, he tells exactly this great story. And if you look to an iMac, it somehow resembles to what one of these nice sunflowers they are. So what I'm trying to say is that we have to learn from all the domains. If we want to really understand what Health 4.0 is, we have to understand what the other domains are doing in this transition to their 4.0 in their specific contexts. So you also have a specific, now somehow going a little bit deeper, or not deeper, but somehow resembling you guys in the medical domain. So there is a company, a German company called Braun, that in 1988, they had this hyperthermia radiator here. And in 2003, we had this eyesight camera from Apple. And you can see that there are some similarities. And I'm not saying that Apple is always copying ideas from nature or from other companies. That's not the point. But they get inspirations, and then each one develop their own concepts. So, and then in order to somehow bring us to this notion of Health 4.0, I would like to explore with you how this whole 4.0 wave is moving on in other domains. For instance, if we go to in the agriculture, so agriculture 1.0, it was basically based on these small families, right? We had families that they would harvest for their own. So a family of 5 to 10 people. And then you move to the agriculture 2.0, so to say, that this year happened in between the decades of 60s and the 70s. And they had here what was called the Green Revolution. Here, it was exactly the point when chemical defenses, they started to come in place. So it was not only about producing for small families, but how to produce in bigger quantities without somehow losing the crop. So this is the advent agriculture 2.0 of chemical defenses. And then we jump into agriculture 3.0. That is when we talk about guided machines. We talk already about different apps and different source of information. We already have drones, we have tractors that they drive by themselves. So this is exactly what we have here on this left-hand side of this slide. And what we have, although, in our experience, that we also have some projects going on in this domain, is that the farmers, if they do not get the proper insight, they will be overwhelmed with the amount of information and they will be somehow confused. In the future, or where we are transitioning now to agriculture 4.0, is that the farmers and any operators, they will have insights. They will have connected devices that will not only shoot a wave of information, but they will have knowledge at hand for the farm systems. This is somehow what is happening into this transition in the agriculture world. You can also do a parallel with another example here in the Industry 4.0 domain. So yesterday here in the IESE, we had our tutorial on Eclipse Basics, which is basically one solution to enable the development of Industry 4.0 applications based on digital twins. So you had here 4 revolutions. One is starting with pure mechanic machines. The second industrial revolution, it happened around the 1870s. And here we had, when we had all these transportation belts that we could transport a multitude of different artifacts being produced or being processed in a production plant. And then in the 1970s, you had the advent of the PLCs, or program logical controller. And here we are now into this transition to the 4th industrial revolution, which is a computer-based revolution. It's about connecting things, it's about providing insights to the different stakeholders that would consume this information. If you make a comparison to what we had here before in the agriculture 4.0, they have certain similarities. And the question is, why can we not explore this in the health 4.0 domain? We should somehow explore this with a similar mindset. Independent, if we're talking about health 4.0, industry 4.0, whatever 4.0, there are some concepts that they somehow belong to this transformation that the world is moving on. And I would like to share with you some examples in these domains, closing, of course, with the health domain, how you guys can get inspired on that with respect to artificial intelligence, intelligent and autonomous systems, big data, service orientation, and user-centered. So when it comes to artificial intelligence, there was one article from John Deere in their webpage. You can see that this was, it's not that new, it's more than 3 years old already. But John Deere, they bought one startup from California called Blue River because they had sophisticated technology to differentiate automatic identification of what is a crop and what is weed. So this is somehow what you can see here in this picture here. So I also put the link here that later on you guys can have a look at this. So if you look to the first image on the left-hand side, you cannot really identify what's crop and what is weed. But with this technology that they acquired that have advanced machine learning capabilities, they can identify with precision what is a crop and what is not. And you might ask, okay, so but, and what? So for this small example here, you might not see the whole problem that we do have, but if you try to put the things in perspective, guys, how do farmers, they get rid of what is not crop or what is not what we are supposed to consume? They apply the chemical defenses, everything overall. They do not care if that's gonna be a crop, if that's gonna be a weed. They put in an amount that will not, that is of course regulated, that will not cause damage to our bodies. But with this new technology here, you do not have, you can only focus and apply chemical defenses and exterminators for what is not to be crop. This kind of technology is already experimental in place, and there is this report here, or this quote from a Texas cotton farmer saying that this kind of technology here is already substituting the work of 8 to 10 people that were supposed to execute this kind of activity in a field. So everybody here has an Alexa these days, or most of you have an Alexa these days, or at least know what Alexa is, or the software that runs in these Amazon Echo devices. So interestingly, when it comes to health, the Boston Children's Hospital of the Harvard University is developing some kind of technologies that has artificial intelligence embedded on it to support people in early diagnosis at home. That they do not go to the hospital if they feel the first fever, if they have a first cough. So I'm gonna share, this is a video here, I'm gonna hit the play. I think the audio should come to you, or it did not. Hang on. Strange, it's being shown as an image. Okay, don't know why it's that. But basically what we do have here is the following. So you're gonna ask Alexa, my son has a fever. And what's gonna happen is that Alexa is gonna start to make you some questions. What's the temperature and what's going on, if there are all the symptoms. And you are talking with that, with Alexa. And then it's gonna come to a point that she's gonna tell you what you should do in terms of medication, what you should take in terms of medication. So, and the question is, okay, so very nice to have this technology, but I do not know if I would trust something like this if I'm talking about my children. I would like a doctor to look at him. Interestingly, they conducted a survey, and I put this here, and you see that this is from 2018. So more than 50% of the people, they are confident about the reliability that this Amazon X application is delivering with respect to this initial diagnosis. 7%, they were very confident, and 68% of the responders, they say that knowing the content comes from the Boston Children's Hospital, it would increase, they would trust even more on the information being provided. So one of the key takeaways that we can have from here is that the institution behind the technology is what is driving the overall reputation here, right? The technology is somehow consolidated, but the point is who is developing that. Another example in the medical device domain, and this here is more in the personal device domain, is being developed by this company called Omron. And they basically, you can have here an app, you can have a device that's gonna be attached to someone with high blood pressure. And you can say, Alexa, what's my blood pressure? And then Alexa is gonna somehow trigger a series of commands, and it's gonna just trigger the process of measuring the pressure, right? The blood pressure. And then you can ask what's the average blood pressure and stuff like this. So if you consider that one of the procedures that people that have high blood pressure, they have to measure the blood pressure very often and take notes so they can go to the doctor and give some kind of prognosis for a more accurate diagnosis. Having something like this, you can say, Alexa, send my blood pressure report to my medical doctor, and then he can have a look at it and say if I should go there or not, right? Especially these days that we're somehow avoiding go to the hospitals because of, or to even to medical practices. This is something very relevant. Of course, there are things to do with regulations of sharing data with each other, and that's the point. The technology is there. So what I listened from from the innovation chief of one big hospital that we work with, he made a very interesting point. He said, in the medical domain, or the medical domain is the one that provides more technology innovation than any other domain. But we are the last ones to somehow adopt that in reality, because the whole certification process is very long, of course, dealing with patient health and so on and so forth. Yeah, this is just some Alexa commands that you can still have with Oral. Another example here that you would have here would be like, so what some hospitals are doing, and I have already seen one of them, they have like Echo Dots. There's a small version in each one of the bedrooms of the patients, and they can simply say, Alexa, who is the nurse in charge, or can you call the nurse? Or you can have something like this in that management area in the infirmary, and they can say, okay, how many beds are available in one specific ward? So the overall coordination is somehow being done with voice being processed and informations being provided by a complex ecosystem. And everything here, they have a sophisticated artificial intelligence behind processing everything to somehow deliver the information that would be more adequate for one specific point. For instance, who is in charge in the South, on 7 South, that would be one specific unit. So one of the things that they do here as well is like they're piloting real-time hands-free voice prompted organ transplant checklist process. And this is just amazing. So it's still, there is the CDERS C9 that in this specific case, they have specific cases that these Echo Dots, they are placed in the bedrooms of the patients. They're simply saying, Alexa, change the channel to ESPN. So usually when patients cannot do that, when they have some kind of debilitation that they cannot move, they have to call the nurse has to be walking, and the nurse is walking from one bed to the other. So that can also be, this is also desired to be reduced, because every movement that happens, even if you take all the measures that you can, they might result in some kind of infection transportation. And these are just some other commands like, Alexa, I need pain medicine. And then it's going to be a connection from the Echo Dot to the medical center. Yeah, this is just some reports that, for instance, in this case, an assistant nurse manager said, whereas previously nurses were frequently asked to help in a room with television, now they are simply doing that automatically. So when it comes to autonomy, in terms of autonomy systems themselves, I think you recall artificial intelligence and then autonomous systems. So in April 2018, the FDA granted the first approval to an autonomous AI-powered medicine device that was to the diagnosis of a disease called diabetic retinopathy. And this is basically the name of a disease that is based on the eye. So it happens in the eye of the individual. And this device here, it does the overall processing and diagnosis by itself. So the doctor is basically putting the patient in front of the machine, and the machine is doing the overall procedure. So it was the first autonomous AI-powered medical device approved by the FDA. There are just some statistics about that, like the software correctly find the condition in 87% of the time, and correctly found the absence of condition 9% of the time. This is pretty high, right? Because we're talking about autonomy, there is a very interesting thing that we can also learn from other domains, like in the agriculture domain, and I'm making this pattern here for you. In the agriculture domain, there is this machine. It's called a cucumber flyer. So cucumber flyer is basically a machine that people, if you see here in each one of these wings, you have individuals that they are somehow laying on one specific bench, and they are collecting here, harvesting manually cucumber, right? And what these people are doing, and the labor that these people, they do have, is it's not cheap, right? Especially in Europe, in Germany, the cost per hour is not something that is cheap. And then what happened was that the harvesting, and this is documented, the harvesting of German cucumber, it was shipped to some countries in East Europe and in India. And then there was this initiative here to have a machine that they could somehow reduce the costs of this overall manual labor. And then they had, it was a project called CATCH, developed with a sister Fraunhofer Institute, the Fraunhofer IPK. And they developed this small robot here that has the size of a regular chair. And what they do have there is that this one small robot is doing the work of 21 individuals. So if you have 10 in each wing plus one driving the machine, this is being substituted by one of these robots here. I know that there are social implications on that. And what is interesting is that I was already asked by someone from one of these labor agencies how they could somehow, what is coming in terms of technology innovation, so we could somehow support, they can be ready to transition those individuals in a mark reassignment. In the transportation domain specifically, so there is this, talking about autonomy, you have this Audi A8 from 2017, and this car here is pretty sophisticated. It has like 41 assistant driving systems. They have this button here that I circulated in green, is this that offers facilities to advance the driverless system through this Audi artificial intelligence button. And they have here like traffic jam system level 3 on highways. So the car would drive by itself almost when it's driving up to 60 kilometers per hour. They have parking pilot level 2, like it can really drive the vehicle from one parking space or to one specific garage. For legal reasons, this TJA is not activated. So the initial claim was that this would be available 2018, 2019. So Audi made a recent announcement saying that they will discontinue this functionality, at least for the moment, because of the traffic regulations for that. So this is another example that the technology is there, but the question or the main issue is that the overall technology deployment is not that easy because of the certification processes and so on and so forth. What is absolutely understandable, and one key message that I share with you guys here is the following. So it is great to develop new technologies, to dream, and to do all those things. But we also have to be somehow understanding what is in sync with what the context is providing. So how long it would take until this technology will become in place, right? So this is very important to consider. Autonomous medical devices, you might ask, is this a reality? Yes, this is a reality. So in 2019, 30 of April last year, I put the link here on the bottom of this slide. There was one article talking about a robotic catheter to autonomously put a valve in the heart of the individual. Let me clarify this here to you. So some people, they have heart issues, and when they have to do a procedure to fix that, the doctor has to put one catheter, something like this that you'll see here with this white head, and it will drive, or the doctor will go all the way to the heart of the patient. He will go all the way to the heart of the patient. Whenever he reaches the heart of the patient, he put the valve and he returns. What's the big challenge here is that the blood flux can be different. So if people can have some kind of, might not be anatomic conventional, they can have some kind of deviation in the veins and so on and so forth. And the idea is that they could have everything here done autonomously. What exactly does this mean? It means that the overall procedure done autonomously is that the doctor will make a small incision. He will place the catheter at the very entry of the vein. It can be on your leg, for instance. And then this catheter is going to go autonomously until you reach your heart. When the catheter reaches the heart, it gives an indication to the doctor that he's monitoring everything. And then the doctor takes the control of the equipment. he places the valve and then he releases, and then the apex is gonna somehow, the catheter is gonna come back alone again, identifying what is the speed it should take, because the blood flow can be too intense, can be too weak. So this is somehow how the things have been done into this, in terms of autonomous systems in the medical domain. So I put here the reference for this, or at least where you can find this here, the title of the article. And this has been developed by these three institutions. The Boston Children's Hospital is the same one that provided that Alexa facilities for children care. This iCube University in Strasbourg, and this Taipei Veterans General Hospital in Taiwan. They tried that here. Just put a quote from the article, that in an animal model of cardiac valve repair, the team programmed a robotic catheter to find its way along the walls of beating blood-filled heart to a leaky valve without surgeon guidance. The surgeon would basically make the incision, release the catheter, and then when the thing is there, he put the valves, and that's it. The guidance is autonomously. When we talk about data, so in 2018, the Forbes had this new, that data is the new oil. And that was interestingly that it followed this magazine from The Economist, saying that, of course, we know that the data is the most valuable resource we have these days, right? And then Intel, coming to this overall notion of intelligent systems, autonomous systems, Intel conducted one study in 2017 saying that 4 terabytes is what is needed, or is what's going to be generated by one autonomous vehicle in 1.5 hours driving. This is a lot of data, guys. This is a lot of data to be generated in 1.5 hours of operation of any machine, right? If you imagine a tractor driving some kind of harvesting activity, a car driving in a highway, and things like that. So to store this amount of information here, that would request a lot of storage capacity in one vehicle. That would start to make the vehicles too heavy, consuming a lot of fuel. So this has a lot of implication of this data. Like, this data has to be sent somewhere else. And then we have here network challenges that has still to be won. Like, how am I going to transport all this data here? It's not simply about generating the data, but what do I do when I do not have capacity to store the data, and I do not have the technology to transfer the data with accuracy. And in this case of Intel, for instance, it has data generated from different systems, like cameras, radars, sonars, GPS, lidars, and so on and so forth. They go from technical data of the vehicle, crowdsourced data, like, or even personal data. Like, I like to drink a coffee in Starbucks, and whenever I pass by a Starbucks, the car system, the infotainment system, identify that you are close to that and say, hey, would you like to stop for a Starbucks? That's basically what this type of data is being generated. When it comes to big data in health, so the goal here in terms of health is to use, as I wrote here, to use large volumes of medical information to look for trends or associations that are not otherwise evident in smaller data set. And you have companies doing that, right? So you have Google, Amazon, Netflix, Facebook, and everybody has, data is what they do with the business of, or most of them. So we have here the challenges regarding free and open access to data, providing what willingly to the customer. You can directly deliver the data or centrally to the company. But when it comes to health, the point is that the privacy issues, they become even more strict. Patient data is something that is very complicated and a challenge to be shared. So they have to be carefully guarded. They are not openly available, and they belong somehow in a silo in a clinic or in a hospital. Like, this kind of data, they cannot even reach in some cases like the internet. Yeah, that's the point. There is no central sharing. And the question that we ask is, when it comes to smart health or health 4.0, is how much more data do we have to acquire to somehow enable this 4.0 wave in the medical domain? So, and then I put here a collection of assertions that I have collected with the different projects and customers we work with. Like, they have to predict the daily patients incoming to tailor staffing. Like, it's not that you're going to have all the staff available the whole time. That's not the case. That cannot exist. It doesn't hold, right? So they need some kind of data that's going to be somehow processed with sophisticated heuristics to tailor staffing assignment. There is one company here in the northeast of Germany that what they're doing when it comes to data is also is another use case. This is for intelligent monitoring of infections in hospitals. Like, as I already spoke to you before, with the nurses going from one room to the other, is that they are vectors of bacteria and viruses if they do not take the adequate measure. What this company is doing, they are somehow putting sensors in alcohol dispensers, and also some sensors that they should be carried by the medical professionals during the whole stay in the hospital, during the whole rotation that they are working at. And what happens here is that whenever the doctor or the nurse crosses the border of the patient room and do not use the dispenser of alcohol, it starts to become statistics, as you guys can see here. Like, this is basically showing who is using alcohol and who is not using alcohol, the percentage of usage of alcohol, and so on and so forth. So is data being used to somehow also increase the care that is being provided in the hospitals? So this also goes with the enhancement of patients' engagement in their own health. Like, when you think on all these things that are being provided, like in terms of data, that you have a software that can somehow send this information or share the information that you do have with your physician, and he can say, hey, you should double the doses of the blood pressure medicament that you're taking. So this is something that can be very done. So most of the companies, most of the hospitals that we have contact with, I ask them, okay, so what are you planning to do in the next 2 to 3 years? They say, we would like to have as much wearables as possible. So increasing sophisticated watches and many things like that. This is exactly what these guys are looking forward, that the patient, they can also be involved in the diagnosis and in the therapy process. Help improving in preventing opioid abuse in the US. This is also something that they think data should be acquired. Use real-time alerting for instant care, preventing unnecessary ER visits. So if you have a children here, you will understand what I'm saying here. So I remember when my daughter, she had her first fever. I was somehow crazy at home. I was a first-time dad at that point in time. Okay, what do I do now? I took her to the ER room, and the doctor said, okay, first-time dad. Okay, just go home and do that. So you learn, right? But ER, they are not places that you should make a Sunday evening visit constant. So we should know when to use that. So, and this is exactly the point, that data could somehow support this kind of initiative. Integration of medical imaging for broader diagnosis, in-depth analysis of cancer treatment, like artificial intelligence together with some heuristics and data analysis, they can really indicate with a high precision what's the degree of some cancers, even if some of them are still in the very beginning, that they are not detected by sophisticated machines like an MRI and by some computer tomography. I was in a scientific jury last week of the Fraunhofer Society, and I was impressed by how they are using artificial intelligence and analyzing huge volumes of data, not only to deal with cancer treatments, but also to do a precise navigation in brain surgery. like robotic navigation of brain surgery. It's just amazing what is happening there. Reducing fraud, on enhancing data security. This is more on the authenticity and what's the value of the information that is being provided here by the patients. Telemedicine, that is very important, especially these days that we live in the pandemic. Telemedicine has been something that has been very appreciated. And then we go to IESE as a service, or this service orientation. Like these days, we live in a world that is service oriented. So you do not have own a car anymore in big cities. So you Uber. So like Uber became like a verb, right? Netflix, Amazon Prime, Amazon Music, Spotify, even sharing cars. You do not stay in a hotel because it's too expensive. You stay in an Airbnb and you deal that directly with the owner of the apartment. Everything became somehow a service these days between two peers. Like how is all the domains doing service orientation so we can somehow inspire in the medical domain? Like John Deere, together with these other companies, they implemented, or they are implementing, service orientation in countries like India, South Africa, and some other countries in the Middle East. So it's too expensive. It's too expensive for them or for a farmer to somehow have a big machine like this. What do? Is that they offer as a service. The individual does not have to have the machine. He pays by the amount that he's cropping. So this is very interesting. There are other companies using, trying to address that in another perspective. They build small robots that, for instance, this one here is used for seed. This is an English company called a Small Robot Company. So, and they rent these small robots here, and they're very sophisticated, and they can really somehow help people that are in the agriculture domain, but they do not have the money to somehow handle this overall thing. So when I talk to companies about, or not companies, sorry, when I talk to hospitals and specialized medical practices about medicine as a service, so I could not talk to any one of them that they said medicine as a service for me would be characterized as this. I never got something that I could say, okay, so those people, they see medicine as a service as being this here. So I put this image here because I think that some of you are familiar with Star Trek, and they say that this is the analogy that I do. So medicine as a service is like the Star Trek Enterprise. Is something that is only in the dreams. We do not know exactly, not even what we want. If we do not know what we want in terms of medicine as a service, we do not know exactly what to develop. And that's a big challenge. So this is a big trend. Service orientation in the medical domain, how to do that. In the Industry 4.0, we are doing here at the Fraunhofer IESE a hell of a work in tailoring the traditional SOA concept, like service-oriented architecture, for production lines. It's not trivial. And I see this as a big potential to run and do something like this in the medical domain. I'm coming to an end, guys. User-centered, this is something, of course, that is a key for Health 4.0. So patients, as we said, the patients, they're looking to someone, to a medical doctor or to a medical facility that they could give attention to them, that they can really sit and talk and not only say, okay, you are here, go to that room, they're going to make an x-ray, they're going to do a CT, they're going to do an MRI, whatever, and then come to me. The doctor even does not look at you. No. So the idea now is that you can have really doctors that can offer this kind of a conversation with the people, and they can say, hey, I have this specific need. Can you please help me out with this here? So there are some companies that they're even offering tailoring for wearables, and even for some applications to be used like in an Amazon Alexa Echo or in a Google Home. that they can be specifically tailored for specific individuals, specific elders and people with some special conditions, like people that had some kind of dementia and multiple sclerosis and stuff like that. We have to keep in mind that not everybody that suffer from these drastic diseases, that they can live by their own. They need some kind of assistance. And we are heading towards the assistance going to be given by some kind of electronics that should be there to really support those classes of people. This is what I had to share with you here, guys. I hope that you could have some kind of inspirations on what Health 4.0 could look like, be inspired by other domains. And this is the check here. So these are somehow the trends. I do believe that you are familiar with most of the things that we discussed here. But the challenge, believe me, as I have been talking with you since the very beginning, we have the technologies. The question is, how do we instantiate them to one specific domain? And do not do the make the mistake to assume that just because we already have artificial intelligence in cars, that we can do that for one medical device or to an airplane to that degree. That's not the case. Do not forget that the medical domain, as many other safety critical domains, they are strictly regulated. They are strictly regulated. And if we try to be dreamers and great engineers without considering exactly what are the demands of the certification authority as the stakeholder, we might hit a dead wall. We talk about, we are in the main architecture conference that we have all over the world. So when we talk about architecture drivers, let us always think, so what's going to drive my architecture? We have to think in things that are new, expensive, and risky. I'm not the one that I say that, so everybody that talks about architecture understands this. And we have critical stakeholders in place. Let us not forget that everything that we do in the medical sector is extremely critical, And we have to consider the certification authorities as a key giver of architecture drivers whenever we are architecting this kind of systems. I hope you did not fall asleep. So if we were together in Salvador, I'm pretty sure that we would be in the sun. But now that we are online, I hope that you're still with me here. And I made this whole thing here, Elisa, a little shorter than you planned, so we can have some conversation if the audience is interested.
Okay, thank you very much, Pablo, for your great presentation. Always very good. Thank you very much. Yeah, now I would like to say we have some time. We have 7 minutes for some questions. Please, the audience. Pablo, I think I will use the silence of the audience to provide my question for you. Okay?
Sure, go ahead.
Health 4.0 is a very complicated domain, yeah? Like Industry 4.0, which is the big challenge to adopt Industry 4.0 system widely in the hospital or in the health system, in the public health system, for instance? Which big challenge?
So one of the biggest challenge, Elisa, that I have heard when I talk to people in adopting 4.0 technologies in the hospitals is because whatever comes for the hospital in terms of technology, they are very, very expensive. They are extremely expensive. So the technology takes a lot of time to be embedded because of the criticality that we already spoke about. And there is one way that these people are somehow, that these different hospitals and medical device producers are doing, that is on doing partnerships. So I had here some backup slides that I could share with you. In just 1 second, I'm going to go through it to talk, because I imagine that something like this would come. If you look, oops, you do not. Yeah, of course, I closed my PowerPoint. So, do you see my slides again?
Yeah.
So if you look here at this slide here, oh, come on. So one example is like Roche that produces medicines and technology for health. They are partnering with General Electrics. They are somehow joint forces to provide this kind of technology for individualized treatment and early diagnosis. So, and they make it public because it's great to do that. Like Philips, that is one of the big medical devices producers. So they made a 15 years partnership contract with one of the biggest hospital in Cologne here in Germany, that they would say, okay, so we're gonna deliver everything that Philips is doing new in medical devices. We're gonna give it to you. It's a partnership, but what Philips wants in return? Who guesses here? What Philips wants in return?
The data.
Anyone guess?
The data.
There you go, and that's the point. All that they want is data. So that is the same that they're doing with hospitals in Munich, optimizing technology, but all that they want is like data back from the patients. They are also doing things with hospitals in Australia. And you see that this is not, Elisa, 1 year partnership. They are doing 15, 20 years, 8-year partnership because they understand and they know that the technology takes a while until it reaches the stage that they want. But everything that they will do is to receive the data. So they're gonna somehow use the data patient to understand what are the demands to increase and improve their technologies. So this is a big challenge. Like this technology is there, when the certification barrier is through, then you come to the cost of these equipments. They are very expensive.
Okay, then when we talk about Healthy 4.0, we are talking from now on, from the next 3 decades or 4 decades. Yeah, this is the real for the future, not for now.
This is something that is still on, is still being developed. So I watched it. I was in the audience of a talk that was given by the CTO of Philips. It was last year in the Netherlands. It was amazing, the talk that guy gave. And he was saying that Philips made a strategic decision. It was to a big audience, that Philips as a brand, it will develop from that point on only equipments for the medical sectors. Any other equipment that we see with the brand Philips, they are produced by another company because they are focusing everything in the production of medical equipment. If you have a coffee machine with the brand Philips, it's done by this Italian Saeco. If you have a TV with the brand Philips, it's done by Samsung and things like this. And that's what those guys are making things available, you know. And this is exactly the prognosis that he says. In order to have something like this ready in the hospitals, the technologies like based on digital twins and stuff like that, ready in a hospital, this is a 20, 25 years minimum.
Yeah, good. Another question for you. Thank you for your answer, Pablo. It's very, very clarifying for us. Yes. I think the audience has other question. I think I will use the last.
I have a question for Pablo.
Sure.
So Pablo, congratulations for your talk. I really appreciate that. It was very, very nice. And I have a question, and the point is to know what you think about this aspect, because one of the kinds of application that you are talking about is about getting data from patients. So for example, if you have like a small device at home or in hospitals, and you can use in your smartphones. But I think that maybe 1 or 2 weeks ago, one white paper talked the different results about the getting data from the different device. So, you know, in this kind of domain, it's quite critical, right? Because if you get you can have your machine learning model working very well, your artificial intelligence work very well on the cloud, etc. But if you are getting the wrong data, everything is messed up.
So I think Eduardo is done, right? So yeah, sure. Let me share, Eduardo. This is a great point. Like the point is, what's the accuracy of the data that we're retrieving, right? So I think that is exactly the point. So because you can have the most sophisticated AI, but if you're processing in a set of data that is not consistent or data that is somehow even wrong, you're going to deliver wrong results. So I placed a very similar question, Eduardo, to one cardiologist. And I'm going to share with you what he told me, okay? So he told me the following. So the Apple Watch claimed that they did have the capability to perform all these cardiac analysis with a lot of accuracy. And what they did, or with some hospitals in Germany and some hospitals in France and even some hospitals in Brazil. One of these three big hospitals in Brazil, they did one joint experiment with a traditional equipment to measuring all these cardiac analysis, and they indeed identified that the methodology that was used by the Apple Watch is not accurate. They're not delivering data that matches with what the traditional cardiologist equipments are using. Now I come to the point why these hospitals, they're investing a lot in wearables, is because these hospitals, they're simply not buying wearables to give to their critical patients because they do not trust on the technology and on the medical methodology being used to acquire this data. And this is exactly a big potential here, because these big hospitals, they are interested in partnering, not with the big players, not with Apple, not with Google, not with Amazon, but with the small companies, even with the startups. They can buy a hardware and they can implement their methodology. So they are, in this case, much more interested in developing something smaller for their context that delivers accurate result than having a generic solution. And I have observed that in these three different countries that I have mentioned to you, and they are not small hospitals. So one of them, they really tear a part of the hospital down and they build a new hospital with a complete new concept. Very interesting to do stuff like that.
Thank you, Pablo, for your explanation. Yeah, I completely agree with you. Mm-hmm. I'm involved with a small startup company here in my city in Salvador, and we have a cardiologist also on the team. So yeah, we are facing these kinds of discussions while we are creating the first product. Yeah.
Yeah, absolutely.
Okay.
Keep in touch.
Let's do that.
Thank you. Hans, please, your question.
Yeah, thank you. Also like your talk very much. Very nice description of what it can lead to, even if we don't know yet the final destination. But as a security or cybersecurity guy myself, I would like to ask the obvious question: how much dependency can we actually have, or should be allowed to have on that technology if it's there in the end? And how much, because you mentioned the sensitivity of and the criticality of procedures or anything that's connected to patient health, and how much dependency can we allow? How much fallback to manual procedures do we need to ensure that it's still in the practitioner, so that if somebody hacks it or if a denial of service happens, that we are prepared and that the patients are not at a loss?
Yeah, so Hans, thank you so much for your question. I believe that as a security expert, I do not know if you heard about the HL7, the F here. So this is a platform, or let us call it the technology, that is supposed to enable secure interoperability between different medical devices. This is really dedicated and is specific for the exchange of communication in the medical context. let me share with you what I have researched and or what I have observed here. The question of what you should observe, what you should hold, what you should take care, what you should expose, what not to expose, this is intrinsically related to the legislation of each country. Let me give two examples for you here. One is this one, right? This is about the ELGA. Like ELGA is a system in Austria where everybody can have, like, so to say, a medical profile. All the information can be concentrated here. All the diagnosis, the prescriptions, everything takes in place and stay there, right? When you go for, and here comes exactly what is this e-medication. In Denmark, they also have something similar about that. They have very similar things here. When you come to Germany, for instance, one of the big challenges is about the confidentiality of data. I do not know, I think you are German by your name, and you know how hard the thing here is about sharing this overall information among the different entities, right? So this is a challenge, and I do not have a black or white answer for you. What I can tell you is that we know that people are working on that, but so far, the progress, to my understanding, is very low, is very, very slow. And we do not have something to say we're going to be hold the things like that.
Thank you for that answer with regard to the data and privacy aspects. I was more referring to the operations, so the A in the CIA, the availability of such services and mechanisms. Everything is interconnected even more than today. Yes. And if I want to attack this, or if I mean the opportunity for ransoming somebody for releasing a service or blocking a service, that it increases well, exponentially with the number of services connected. And I mean, what we see today is somebody spreading malware on the EHR or the IT systems in a hospital. This is just a little inkling of what we will see in a future where we even more depend on digital services.
Yes, it is. So all these digital platforms, they are increased susceptible to stuff like that. So in the automotive domain, let me make another parallel here. In the automotive domain, I think you guys are aware of this safety integrity level of the functions. Like you go from safety integrity level 1, where it's just the function in the car that if it stops working, the car can still keep driving and no one will die or have an accident because of that.
Like
on the other hand, was that?
Like manual takeover in such scenario?
Integrity level 1 would be, for instance, if your radio stopped working. Mm-hmm. So an integrity level 4 function is a function that if it fails, someone's gonna die, or you might have a hard accident, like the braking system did not respond, the steering system did not respond. I did a work with a research institute in the medical domain 2 years ago. And one of the things that we tried to do was to do an instantiation of these concepts of safety integrity level from the ISO 26262 from the automotive domain to the medical domain. Then you could have a set of functions that you could have in a medical equipment that they are critical, that if they fail, the patient may die. For instance, over radiation, right? If someone is doing an X-ray, stuff like that. And then what we have to do is to somehow act on special protections for those, even not allowing them to be accessible to even to the intranet of the hospital. That would follow somehow the same separation principles that we do have in a car. Like if you look in a vehicle, like the functions that they are executed or they have safety integrity level 4, they even do not have interface with the other parts of the systems in a very easy way. So the protection would be not to put the functions there, but is to identify what are these critical functions, and then to put the adequate measures to protect them.
Okay. Thank you. Sounds like an interesting concept.
Yeah.
I guess this will lead to a separation of the data that might be necessary to operate the service.
Absolutely, it will. And one of the things that I have seen is now we are talking about somehow moving into data science. That is exactly something that has to be considered. So when you talk about diagnosis, we are so concerned about the sensitivity of the data, but we forget that, as you said, in a platform like that, if you put them in the internet, a hacker can come and can simply configure the system to release a high dosage of radiation in someone doing an MRI, for instance, and you make everything broken. So it's really about the protection of the equipment itself, right? Protection of the function. And I think that we have to improve a lot the work at the architecture side. Really the work at the architecture side of the system to identify, okay, so what functions are risky to this level with this classification?
Mm-hmm. Thank you so much.
Yeah, my pleasure.
Okay, thank you for your question, Hans. Vlad has a question. We will not have a first presentation of section 1 because Yvette just sent an email for us saying she just lost her father to COVID. Then we will not have a first presentation. Then we can extend a little bit more your discussion, Pablo. Then, okay?
Sure.
Yeah, Vlad, please. You have a question here in chat.
What kind of data can they get in such a privacy-intensive domain? So, Vlad, if you cannot talk, do you mean like what type of data would be susceptible to be acquired by a hacker in an attack situation like Hans mentioned? Is this what you mean here?
Just a moment. Okay, I was on mute. No, the question was related to your earlier comment that manufacturers are partnering with hospitals in order to get data. Mm-hmm. And I was wondering, like, what is the nature of that data? Because due to regulations, privacy, and other concerns like this, you lose a lot of context about where the data is coming from. So that's kind of interesting.
I understand. I think I understood your question. What you're talking about is like the part. I'm going to rephrase your question to check if I got it fully. Okay. So you were saying you are referring to these partnerships that I have mentioned before, that the medical equipment producers, they deliver the equipment and what they expect back is like the data.
Yes.
And you would like to know what do they receive because context is missing in this case, right?
Yes.
For instance, imagine that to do an image analysis of one specific type of cancer. You have to feed your system, your AI, with as much images as possible, right? So then as the bigger the database is, the most trained your neural network is going to be, and the more accurate the results are going to be. So this is one type of data that these people are looking for. They can have a data to say, okay, this guy has a colorectal cancer that is already in stage 4. This is what characterizes, according to the doctor diagnosis, a colorectal cancer stage 4. This is stage 2. And then they can, of course, train technologies like this to perform even intelligent diagnosis. This is one type of data, okay? Another type of data that they can do have here is like, of course, how the hospital is, and again, in order to disclose the diagnosis of someone, they do not have to disclose the name. They do not have to disclose stuff like that. So, and most of us, depending on the hospital that we do go, we sign all that papers. I agree with everything. You are in the hospital, you are in pain, and you are doing stuff like that. You sign the papers, and sometimes you even do not pay attention on what you're signing, right? That you can have this information available. I'm not saying that hospitals, they are doing that. In every hospital, they are doing that. But I have been already in contact with some individuals that they are part of an experimental treatment and they agree to submit their data of that specific experimental treatment for analysis, for the hospital to be somehow, to enrich their knowledge and stuff like that. This is also something that has been taken into consideration.
Yes, thank you. It was interesting question. So, although, yeah, I think that's is a very sensitive area, and GDPR has quite profound implications on this kind of data sharing, where complicated concepts or systems needs to be explained to the user, and they can take actions, they can require you to delete data, ask who has access. So yeah, interesting times in the future.
Yeah, so there is another concept, Vlad, that is also related to your question. I just realized that I stopped sharing. Let me share this here with you. So Philips, this is something that you can check here. I accessed this here in November 18 when I first put this image here. They are talking about building a virtual heart model, a digital twin of the heart of the individuals. So what they do have these days is the following. So what you see here on this very first part is the anatomical knowledge that we do have. If you go to any anatomy book, you're gonna see that the heart is like this, right? And what they're doing is like getting samples of different images of the heart of the individual, like an echocardiography, for instance. That can be one of the cases. And what they will do, they will somehow, in this learning process, create a generic model for the hearts. And they can create a digital twin of the hearts of one specific population, of the individuals from one specific region. What these guys are moving on is on instantiating and evolving that to the notion of digital twins of human body, of parts of human body. In this case, they would start from the results that the AI is already providing. They will enrich that with the specific images of the heart of the individual, and they will create here what they call the adapted model, that is nothing else than the history evolution of your heart. And if someone has a cardiopathy, like a disease in the heart, they can directly say, if we perform this kind of treatment in the individual that has this heart here, we are sure, or we are more sure, that this treatment would hold. And stuff like that. So they are not only basing themselves on the anatomic knowledge or in an echocardiography, because to do an echocardiography, you have to be there in the bed. The guy has to have the equipment here going in your heart. When you have something like this, you are somehow feeding the information with your heart, and then people can make diagnoses even when you are not there, because they can predict what might happen to you. This is the first step towards the so-called digital patient. That is something that Philips is also working on. And I wrote this here, like this was from Henk van Houten, the CTO of Philips, that they are on their way to general anatomic models based on a population data, that they do not capture the unique characteristics of the heart. They do need a digital twin that's going to be exactly specialized for the heart of each one of those. And it's a very interesting article. I recommend you to read. It's on the Philips website, How a Virtual Heart Could Save Your Real One. It's a very interesting thing. And information like this, companies like Philips, they're very interesting to get as much as information as they can, even that are anonymized. They only have to know, for instance, where that guy's coming from, what's the diet of that individual, and stuff like that, you know. Of course, it will depend on the hypothesis that they are trying to reach.
Okay, thank you, Pablo, for your answer to Vlad. Yeah, And I would like to continue to talk with you about this topic. It's very, very interesting for me. Yeah. But we need to go on. And I would like to ask all the audience, open the microphone to say thank you to Pablo. Okay.
Thank you. Thank you, guys. I appreciate your time. Thank you so much.
Thank you.
Thank you, Pablo.
Thank you, Pablo.
Thank you. Thank you, Pablo.
Sure.
Pablo. Yeah, Pablo, I would like that you can participate in the rest of the workshop, but I know in Germany it's about 8 p.m. I think so.
We are we're in winter time now. Is 7:20. I have another meeting starting in 10 minutes.
Okay, no problem. Thank you again, Pablo. And let's to continue to contact with you and try to collaborate. It's a very good opportunity to meet my students. Yeah, thank you again. Okay.
You guys take care. Okay. Talk to you soon. Bye.
Bye, Pablo.